Let's start off with the most basic data type, which is an integer. So the keyword to define an integer is int as such. Int x is equal to 1. In that case, x would hold the value 1. To see that, all we have to do is just, type it on the console. There we have it. Let's say we change the value of x somewhere else within the code. Console.write line x again. There you have it. We have 1 and then 56. Now, the maximum integer you have within C#, you could extract it as such. So int dot max value. This is the maximum integer you can define within C#. Let me erase everything here and just print this out. It is this value right here. As you can see, it's naturally big. So you've got the max value, and if you also got the min value. So running that, it's the negative of the max value. Okay, so that's it for integers. Let's talk about something else, which is floats. So floats contain decimal values. The way you define a float is float x is say 4.5 as such. And as you can see, I have an error over here. Proper way to define it is by ending with an f as such. So printing that out, we'll get 4.5. Let's say you would like to extract the maximum value of a possible float. It is this number right here. And you also have the min value, which is the negative of the maximum value, right? So floats are 32-bit numbers, have more precision, of course, due to their decimal nature, and their precision is up to 7 decimals. So we have 7 decimals of precision. Now, if you want to go higher in precision, you can use something called a double. So what doubles are, so double y is, let's say, 5.9 as such. Console.writeLine, say y. There we have 5.9. The maximum double you can have is the following number. You can go up in precision. The minimum is, of course, as we saw, the negative of the maximum, as you can see here. Now, let's say you're in a situation where you have a float, you have a double, and you would like to add them up. So let me comment this out and this out. So indeed, if you would just add x with y, let's see the output, 10.4. So you can really just go ahead and add a float with a double. There's no problem with that. Let's say you have an integer, so int z is 1, and you would like to add an integer with a float. So instead of y here, I have z, run, and there's no problem at all. You can go ahead and add an integer with a float. And also, you can go ahead and add it with a double, 6.9. We didn't say anything about doubles. Doubles are also 32-bit numbers, but they require, or they have a precision up to 15 decimals. So we have 15 decimals of precision, almost the double of a float. So those are 3 really important data types and used extensively within applications and so forth. Next off is long. So long is also a data type. Long, let's say I want the maximum long that I can get. So it's a long dot max value. And let's print it out. Console.writeLine. This is the maximum long you can have. So long is also a data type. And you also have one more important data type, which is a decimal. It's even bigger than an integer. So decimal max is decimal.max value. Let's call this max decimal. And let's just print it out. There you have it. It's longer than the long. And could decimals have decimal A is, could they have decimal as one might think? No, they're only integers, okay? But they're allowed to range more than integers. So comparison among max of each of the following. So they're all integers, but each one is longer than the other. It means that they are allowed to span more values. To demonstrate this, int max value, let me just copy paste this twice. So long and decimal. Run. Of course, this is an error. Let me remove it. Run. And take a look at the last 3 integers that are being printed here from lines 32, 33, and 34. So as you can see, the maximum integer is the following, the maximum long is the following, and the maximum decimal is the following. If you're sure that your variable might take a value larger than this, you can just go ahead and use a long. If you're sure that your maximum value of a variable could be more than this, you can go ahead and use a decimal. Now let's talk about characters, which are 16-bit Unicode characters. So character is just a character on your keyword. So let me show you what I mean. Say I have a character A, which is, I don't know, the letter E, for example. So if I go ahead and print it out, I will get the letter E as such. Now the other outputs are getting really annoying. We're done with all of those. I'm just comment them out and let me rerun. There you have it, E. This takes us to the other data type, which is strings. And a string is nothing other than a concatenation of characters. Let's say my name, and we have an error because I didn't mention the name of my variable name. And the other error comes from using a single quotation. Instead, for strings, we have double quotations as such. Now let me print it out. There you have my name under the character. So really, those are all the basic data types. We started with integers, then moved to floats, doubles, longs, decimals, what else? Characters, and finally strings. Now there is one more important thing that is worth noting or mentioning, which is the keyword var. Now var, once I define a var as such, var is an adaptive data type, means it could take a double or an integer or maybe a string, I don't know, but its data type cannot be changed throughout the program. So let me show you what I mean. Once I define it as such, let me just go ahead and print it out for you. It's 1. And now let me change its value to 2. Let's see if there's a problem with that. There's no problem. So 1, then 2. Good. Now let's go ahead and give it a decimal. So let's print that out. And as you can see, you have this red marker right here saying cannot implicitly convert type double to int. So C# right here understood that this A is an integer. Let me just change it to a double and voila, the error is gone. There you have it. Because at initialization, the variable was seen as a double. Once I do this, at initialization, A is seen as an integer. Now what about if I do this, A as such? We have an error right here. If I run, the error is saying that implicitly typed variables must be initialized. Now what implicitly means here is that C# implicitly infers the data type upon initialization. So right here, C# understood that A is a double. As such, A is an integer. As such, A is a character. Okay, so once I run, the compiler is going to yell at me right here saying cannot implicitly convert type int to char. Okay, because it's a character. So if I do this, let me change it to B and here to, I don't know, C. I should be able to see ABC, right? So that's it about var. After you initialize it, you could go ahead and change it throughout your program. And why am I saying this? Why am I saying that, oh, I can go ahead and change it as such? Because we have this other data type called const, which means constant. And once you define a const, you cannot change it within your program. Look here, you have an error upon compiling, which is the left-hand side of an assignment must be a variable property or indexer because it's a constant. Once I remove this, all is good. Program will compile. Now, when do you want to use const? It's when you have constants. So let's say you would like to define pi somewhere within your program. It's 3.14 and you're sure that pi is not going to, be mutuated or changed throughout your program. So you just go ahead and say that it's a constant. Now, let's say you want something like a var, but you want to be more flexible. In other words, you would want a variable to be a string and then at the same time an integer, and you would like to switch around. Well, you can go ahead and instead of using var, you can use dynamic. And let's call it B. Let's give it a name. I am a string. So right now, B is a string and it contains the value I am a string. Now let's go ahead and change B to an integer. Now B holds the value 4. So console.writeLine means that I can perform some operations with B. So I can add 3 to it, so that it becomes a 7. So as we see here, this means that B at line 21 was a string, but then at line 23 it changed its data type and became an integer. So how is that? It's using the dynamic keyword. So dynamic versus var. Dynamic allows the changing of a certain data type to another data type within the program, and var implicitly infers the data type of a certain variable, and then it is not allowed to be changed throughout the program. In other words, we say that the dynamic data type is defined at runtime, whereas the var data type is defined only when compiled, and then it cannot be mutuated. So that's it for all data types. Let me erase everything right here and let's start doing some math. Now, there might be one data type I didn't mention, which is the Boolean, because I always associate bools with conditionals, which we will be discussing later on in this tutorial, but let's briefly discuss it here because it's really a basic data type. So bool is a Boolean. It only takes two values, which is either true or false. So let's say I have a Boolean which is called can swim, which is equal to true, not try, true as such. So if you want to go ahead and just print it out, it will print out true as such. Now the other value it could take is false. It cannot take any other value. So that's it for all data types. Let's start doing some math. So for this, I'm going to use only the